Coming to you live from Math CNN. I'm Aaron Adams, and I'm breaking news. Mathematicians have discovered a new way for us to simulate motions in terms of a vertical projectile with a given angle. Now, ladies and gentlemen, let me introduce to you parametrics. Not paramedics, even though they do save lives. Now that we have parametric equations, we can model nonlinear motion in a plane. For instance, an object that is projected into the air at an angle of theta with an initial speed of v, we could simulate the motion of that. The object's parabola path can be modeled with parametric equations. Instead of using the y equals f of x form, which does not describe the curve of an object over time like a parametric equation does. Now, let's put the mathematician's new theory into motion, but not projectile motion, but parametric emotion. Now, after a short commercial break, we'll be back to show you how to do parametrics by yourself with Parametrics 101 with my co-anchor, Tina. Cut. Thanks, Aaron. Hi everyone, my name is Tina Richards and I will be giving you the basis on how to do parametric equations with projectile motions with the angle. Now, before one approaches a problem, you should have a couple of formulas in your head to keep handy. So, we have x equals the initial velocity times the cosine of theta times the parametric t. And then we have y equals the v cosine, which is x, times t, and then you add in gravity. And right now, with your class, your pre-cal class, gravity is negative 16t squared. Okay? So now that we have the basics, learn it, love it, know it. Now, here's our problem. David throws a basketball. That's my basketball. You know, Spalding. Yeah, Spalding. Okay. 3 feet from the ground. And this is your initial height at the angle of 30 degrees. So, then you basically take everything and you plug it into the two equations up here. So, we start with x. And the initial velocity speed, I'm sorry, I forgot to mention that, was 35 miles per hour. So x equals 35 times the cosine theta, and the only angle we have is 30, times t. And this will give you the answer for x. After I've done all my calculations, I get 30.31 t. And the t part is your actual parameter. It's the variable that represents the parameter, right there. And then after that, you have to plug it into your y equation. So your y will always start with negative 16t squared for whenever you're doing projectile motion. If you're using a different type of motion, it wouldn't be negative 16t squared. It'll be negative 16t squared, and then you add it to the x that you just found, plus 30.31 t. But then you have to add in your initial height, which was 3. And this is the equation for your parametric function. And just to recap, you should be able to plug in 16t squared, and then you get what you got for x in your equation. You plug it in for t, and then you add in your initial height. Thank you guys today so much for listening to me, and I hope you take this home. And the next time you throw a basketball 3 feet in the air, use parametrics. Thank you.